Okay.
Videos are weird nowadays.
When I do it on here?
You go quiet and then you go loud.
I'm sorry. Okay, whoever's watching this, Carter and
Eli.
Eli's not watching this. Carter. Carter. We went through 24, 10, and 30 real quick. Ellie says that I need to record this for you, so if you want to pause, check that with what you have, but that is what we have. Next.
40.
40. 40. Oh, heavens, evaluate the function if possible. A is cosine of negative pi over 2. Let me write these all down. B is cosecant of pi over 2.
Did we just say what they are?
C, yeah,
So
is cotangent of 5 pi over 2. D, tangent of pi over 2. E, secant of 3 pi over 2. F, sine of pi over 2.
So like on our circles up here we have pi over 2. And
Mhm.
you say cosine of negative pi over 2? So
Yep,
that
where would negative pi over 2 be?
Would it be the 3 pi over 2?
Yeah, pi over 2 from here to here, that's positive pi over 2. So negative pi over 2 is going to go the same amount in the other direction. Cosine is the x coordinate, so he would be 0. 0, negative 1. And you go off the x coordinate, so 0.
Okay, so then
Okay, all right.
cosecant means we flip him, right?
Yeah,
Right.
pi over 2. What's the coordinates for pi over 2?
Oh, wait.
0, comma,
1.
positive 1?
0, 1.
Okay. Cosecant is the opposite of sine, right? Which one is sine, 0 or 1?
So
The y coordinate? Okay, so cosecant is the flip of 1. What do you get when you flip 1?
1.
The reciprocal of 1.
Still 1.
Still 1. Okay, so that's B. 5 pi over 2 is bigger than 2 pi. It's like 2.5 pi, right? Where's 2.5 pi going to live?
Subtract him.
Yeah, if I take 5 pi over 2 and I subtract 2 pi, that's like subtracting 4 pi over 2.
So
5 pi over 2 minus 4 pi over 2 is pi over 2. So I'm looking back up at this guy,
So 0.
and I want cotangent.
Undefined. Right? Tan of 90 is
Tangent of 90 is undefined. So what's the opposite of undefined, or the reciprocal of undefined? 0. Cotangent's going to be 0. Tangent and undefined are reciprocals of one another.
So then
Tangent of pi over 2, that answers your question for this one. You almost had to do D before you do C. Undefined for that one.
And then
Okay.
secant,
3 pi over 2. Where's 3 pi over 2 located?
0, negative 1.
0, negative 1. Secant is
Opposite of cosine.
the opposite of cosine, and cosine is 0. What's the opposite of 0?
Undefined.
Undefined is the opposite of 0. Yep. And then sine of pi over 2, which is this guy up here. Sine is
1.
1. Is that all they were asking? 1. Yeah, there you go.
Okay, so
Lots of stuff.
I just took fusion. I just need to take a weekend break.
That was a lot.
To figure that out.
Yep, that was a lot. Okay. 50.
Oh.
Okay. Today will be a little bit of a step back. It'll be a little bit nicer. Holy cow. 50. Sine of t. This is like a puzzle. Sine of t equals 8 over 17. They say t lives here.
Negative
And find cosine.
or negative 0.4154.
Okay, do you guys like to graph him and like figure out where he lives?
0.8190.
Pi to 3 pi over 2. This guy's going to tell me where he's going to live. From pi to 3 pi over 2. Where does pi live?
Pi lives at the 180.
Right here. Pi is 180. 3 pi over 2 is down here. So that tells me, just this information tells me he lives in the third. So I'm going to draw my triangle into the third. And here's where my angle T lives. He lives right there in that corner. Okay. Now we know that sine is negative 8 over 17. Okay. SOHCAHTOA stuff. Sine is what over what? SOH. SOH. So O is 8. H is 17, yeah? Okay, which guy here is, like, how do I label this with the 8 and the 17?
Like that.
Negative 8 is this guy? How do I know the 17 is not negative?
No.
No.
Because
17 is not negative.
This is never negative.
Right.
Is it?
Right.
Oh, shoot.
Is this guy going to be negative? This top guy right here?
So?
Yeah, because he's going negative, negative, right? So I'm going to put a negative there just so I don't forget. How do I find out what this guy is?
Sorry, Ellie. Okay. Get it?
Sokoto, or A squared, B squared.
Yeah.
A squared, B squared, C squared. So I'm going to go 8 squared plus, which one's C?
17.
17. Okay, B squared. This is a perfect triple.
Right triangle. Oh,
Like it's a Pythagorean triple. He's one of the rarer ones. 8 squared is 64. B squared. 7 squared is 289. I don't know.
I did it wrong.
17 squared. 289? 289. Minus 64. B squared equals 225. Square root of 225 is 15. He is an 8, 15, 17. And the 15 is negative. Okay, we're not done yet, though. They want cosine. Cosine is what over what?
Negative 15 over 17.
Cosine is CAH, adjacent over hypotenuse.
Over 17.
Negative 15 over 17.
Okay, I don't know what.
Yeah?
I did.
What did you get, Dizzy?
I took. I thought that the.
Did you do
17
the-
Was side B.
Me too.
And not hypotenuse.
I did 17 and side B.
Yeah, but that's sine, though, so it's
Yeah.
O over H.
Yeah.
Yep.
Okay.
That would be
Don't
tangent,
we have to
is
try
O and A.
Don't we have
Yeah.
to try and seek it too?
Do we? 50?
No, just cos.
I don't know why I wrote it down.
Nope. Find cosine. Yep, that's it.
Okay. Anybody have?
Okay.
questions?
Anything
Can you
else?
come here? Like, I just do it.
Anything else? Anything else?
How do I do these guys? I don't remember how I do that.
That is a radian to make sure
I know.
Why is this leafy dude all the way at the bottom?
All of these are, that's a radian, that's a radian, that's a radian,
I want to get these
Yes, sir.
these bouquets done by today.
Okay, are we good?
This is the
Pass
last
your
one.
papers for 4-2 in. I don't know, make me a pile over there and a pile over here, if you would be so kind. And here we go.
How'd you do that?
Mo, do you have 4-2 done?
Yep. If you're gonna enter a degree in, you gotta make sure you're in degree mode
I
then.
have 4-2.
4-2. Thank you, Daniel.
That's it.
4-3. If you're waiting, there's the homework assignment for it. It's a little bit shorter, maybe. Nah,
No.
maybe a little bit shorter. It's a little bit shorter.
Oh boy.
Like there's a couple of them on there that's like find all 6 trig functions, so it does make it a little bit longer, but it looks shorter. 507. There you go. 4-3. We probably won't get through the notes today, but we'll get as far as we can get. Thank you for letting me steal your book. Okay. Joe's. You're gonna get that stuck on my head now.
I'm sorry. This is the problem, okay? I am
I'll run and start to play.
What?
I'll start with.
Does everybody have a 4-3?
Do we need our purple thing in there?
You sure?
All
Yes. Yeah. You might need him here in a little bit. Ah,
You broke it.
do you want me to read him? Tate,
6,
you're already through him.
8,
He's already through him.
20, 24, 30, 36, 50.
And you even put the FFA logo on one of your buttons. That is dedication right there. That's dedication. That was a good idea.
That was in Mrs. Boniface's room. Just gold and
Oh.
blue. Didn't print it.
Hey, I didn't do that.
Don't.
Where did she have him printed somewhere?
She just has a
I got a
little.
bunch of them.
Oh, like just stick it that, and that's a perfect size for that button too. Even, I'm impressed. Very nice. Isn't that like a little warm though?
Nah.
Yeah.
I'm dying right now.
Okay. My kids, I buy them little onesies to wear for bedtime and stuff, and they keep them on for like 15 minutes, and then they're like, "We gotta take them off." They're just like suffocate you. There's no breathing. It's terrible. Okay. All right. Did you get them all written down? 4-3.
Yep.
4-3. Here we go. Right triangle trig. This is back to SOHCAHTOA and all the fun things. All right. At the top, let's write some stuff down. SOHCAHTOA. They're going to talk about him in a little bit. SOHCAHTOA. SOHCAHTOA tells you which sides you are looking at for each trig function. So sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. Got it? We remember this from algebra 2 and geometry. Yes, hopefully? Okay, now I want you to circle this very, very important word on the title, and it is this guy. Right. Why is that important? Because this only works for right triangles. It's got to be a right triangle. Now, you can use sine and cosine and tangent and stuff for non-right triangles, but not SOHCAHTOA, right? Like sine, the law of sines, the law of cosines, there's no law of tangents, but law of sines, law of cosines, which we will get to, that is used for non-right triangles, but SOHCAHTOA is only used for right triangles. Got it? I don't know. The law of tangent would be like sine divided by cosine. It's just easier to do sines or whatever. I don't know. Yeah. So anyway, all right. So you have your 90-degree angle. Your hypotenuse is opposite of that. Yeah? Okay. They have to tell you which angle you are dealing with. In this case, they put my angle theta, this little circle with a line in him. He's a Greek symbol. They put him down in this corner. That means that my opposite side is this one. Okay? What if they put my angle theta over here? I'll do him in pink.
Means that your opposite is on the
That would mean my opposite was here and my adjacent would be here. My hypotenuse would not change. True?
correct.
Okay? So, it depends on which side that they tell you or which angle they tell you to what your trig functions are going to be. Right? It?
Never be ever measure these in radians? Are they always in degrees?
So right now we're just going to be dealing with the sides, but when we solve for like these angles, we could solve for them in degrees. Like when we do inverse sine and inverse cosine to solve for the angle, you could put them in radians if you wanted to, if they were asking for that. Yeah, you could. I think for the most part, we're going to be dealing with degrees. I don't know for sure. Let me make sure. Okay, so here we go. 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. If you want to do the little, like, which ones go with which, there they are. They're in order. I blanked these out because we're going to see how much we can remember. Here's where my angle theta lives. Opposite, adjacent, hypotenuse. Circle the 3, the 4, and the 5. He has a special right triangle. You should know that. Yeah? 3, 4, 5. Yeah? Do you know 3, 4, 5 that is a special right triangle? Okay? Also get into the habit of, they will do this to you on the ACT. I'm sure of it. They will do this. They will go 6, 8. What is this side? You can use a squared, b squared, c squared to figure them out, but that is a special right triangle. They're just trying to disguise it because the scale factor is 2. So make sure that you are looking for that when they do that to you because it will save you time by not having to do the Pythagorean theorem. Got it? Okay, here's my angle theta. It's in this corner, not this one. This is the one that we're dealing with. So sine is SOH. So O over H, what over what, according to that stuff? 3 over 5, that's sine, yeah? Cosine is A over H. Okay, that looks like what?
4 over 5.
4 over 5? Is this all coming back to you? You guys know what we're talking about?
Yep.
Okay. Tangent, OA
3/4.
is 3/4, yep. Okay, cosecant.
5/3.
Take sine and flip it. 5 over 3.
5/4.
Secant, 5/4. Tangent, 4/3. You see how I get that so fast? We're just taking the one like up here and flipping it. Got it? Okay. I'm going to try to go through some of this a little bit fast. Yeah? Okay. Good? Okay. Very good. Okay. Unit circle. The sine, cosine, and tangent are using right triangle trig to find values on the unit circle. So like, let me pick on, well, they have 1 there. I'm going to get rid of these numbers. Let's say that we are dealing with 60 degrees. That looks like a 60-degree angle maybe. Okay. In a 60-degree angle, he is a special kind of triangle. There's a 30, 60, 90, and a 45, 45, 90. Yes? Do we remember this from geometry? Some of you guys are in it right now. Okay, 30, 60, 90, and 45, 45, 90. A 30, 60, 90 triangle. Here are the units for him. Yeah, 1, 2, and square root of 3, yeah? Okay, are you ready for this? If you look at 60 degrees, no, just wait. Don't look at 60 degrees on your unit circle, okay? If we're looking at 60 degrees, no, you don't have to, just watch. Okay, 60 degrees is here. If I want to do the sine value, sine of 60, I'm looking at these three being the opposite, hypotenuse, adjacent. Sine is O over H, right? The opposite is square root of 3. The hypotenuse is 2, yeah? Square root of 3 over 2. Let's talk cosine of 60 degrees, right? Cosine is A over H. Boop, back up. A over H. Adjacent over hypotenuse is 1/2, yeah? Okay, now look on your unit circle. What's the coordinates for 60 degrees? Right here. Those. Cosine is 1/2, square root of 3 over 2. That's exactly how the unit circle is built. Is from those ratios, sine, cosine, and tangent, and all that good stuff, right?
Oh, like just threw,
Yeah, yeah.
Threw in triangles like how we threw
Right.
rectangles in for our curves.
Sure. Yeah. Like there's right triangles that are embedded into the unit circle. We'll talk more about like the special ones that go into him here in a minute. Like down below here, I think we talk about those.
But like
So,
they
yeah.
did like the method of exhaustion. For the,
No.
kind of?
No, these are exact values. They didn't, these aren't like estimating or whatever. This is
Right,
exact.
But they're still throwing in like a triangle into the, or like an object into the thing.
Kind of, yeah, if you want to think about it that way. Yeah, that'd be fine. Yep. So anyway, opposite hypotenuse, opposite adjacent. That is how that works for the unit circle. The sine is the y coordinate, the cosine is the x coordinate, and then tangent is sine over cosine. Write that down. Sine over cosine is what tangent is. Good? Okay. All right, let's do some problems here. Example 1. They say, suppose that we have a right triangle and the legs of the triangle are 4 and 7.
So that's not the hypotenuse.
That's not the hypotenuse. The legs are 4 and 7. I don't care how you write this triangle. I am used to putting a triangle like this. Let's make one side bigger than the other, okay?
Like the height should be bigger.
You feel like the height should be bigger? Okay, so let's put him like this. This is how you draw him like in the first quadrant, right? I just get used to drawing. You don't have to draw him in this orientation, but I get used to like drawing him like that because I'm used to putting triangles in the first quadrant. So, whatever. You could face him the other direction. It doesn't matter. But 4 and 7 are the legs. So where does 4 live?
4 is on the bottom, 7 is on the side. I guess
7's on the right side,
since
right?
It's like,
Does it matter?
What?
Does it matter?
No. But just the way that I've written him, I made him taller than longer. So
So if
4 and
7
7.
and 4, since 7 is so much bigger than 4, is it a 60 degrees, not a 45?
No,
Who's the
not
bottom?
necessarily.
So the sides
He is
are-
only a 60-degree angle if he's in the orientation of 1, 2, and square root of 3. So like he would have to be in that ratio.
Okay.
Like this side would have to be 8 and this would have to be 4 square roots of 3 in order for that to be a 30, 60, 90.
Okay, so he could be a 45, 90?
He's only a 45, 45, 90 if this guy is the same as this guy. Right? Like
he's
45
not-
and 45, it'd be this one and this one. No. Which means this angle is going to be like maybe 57 degrees. I don't
Okay.
know. Whatever it is, right?
Okay.
Yeah, does that make sense?
Yeah.
So he is an odd angle measure that we don't have a perfect one for. Yes, good question. Okay, so there's 4 and 7. It says evaluate the 6 trig functions for the smaller acute angle. They have to tell you which angle that you're dealing with. Which one are we dealing with? The smaller acute angle.
One up top that goes
Angle
down.
theta lives up here, right? This one angle is going to be bigger than this one. How do I know that?
Because he's a
The
smaller
smaller
one.
number and you go like the X.
He's opposite from the smaller number, right? This guy's opposite from a bigger number. So his angle is going to be bigger. His angle is going to be smaller. So even if I didn't draw him in the right orientation, I can know that he's opposite the smaller one. Got it? So angle theta is going to live up here. They want the 6 trig functions. Sine of theta, cosine of theta,
Sine,
tangent of theta. Okay, which one goes with sine?
Hold on.
CSC, SEC,
Cosecant.
COT.
Secant. No, you don't have to find what theta is. They just want you to. Oh, yes, we will. Yes. Yeah.
Alright,
Okay, so we got to do those 6 right there. Okay, Reese just asked, do we have to find the third side?
That's 8.06.
No, hold on. We're going to leave him as the square root of whatever.
65.
Okay, so we got to do the Pythagorean theorem. That's the one, that's side C, right? The one that we don't know. 4 squared, 7 squared. I don't know. 4 squared is 16, 7 squared is 49.
65.
So 65.
Oh, yeah, you're going to make
The 65 break down.
8.06.
Yeah, I know. But does 65 break down into like smaller?
No. Nope.
5, 9, 4,
It doesn't.
16. You're just hoping that it doesn't.
It doesn't.
Okay,
I looked at my
all
calculator.
right.
It doesn't.
Okay. You have a cheater calculator that
No,
does
I'm
it for you?
saying it doesn't.
Okay, square root of 65. Okay, we're going to rationalize like we did the other day. Okay, so this guy is, my angle theta is this top guy right here. Let's label opposite, hypotenuse, adjacent. Which side is opposite?
4.
4. I'm going to label him with an O. Which one's the hypotenuse? 65. I went out of order. You guys weren't ready for it. Or you were. Adjacent is 7. Yeah?
Yeah.
Okay, sine is O over H.
4 over 7.
4 over square root of 65.
Oh, never mind.
Okay.
Can we rationalize last?
You want to do all of them first?
Yes.
Okay, sure. That means cosecant is
7 over the square root of 65.
square root of 65 over 4.
Oh, shoot.
Wow.
I'm going the other one.
Why are you going that way?
Because I don't know. Cosine, A over H.
7 over 65.
7 over the square root of 65.
Square root of 65 over 7.
Square root of 65 over 7. Are you guys doing okay over here?
Now we're
Yeah.
Okay. Tangent, OA. You're lost, Tate?
I'm not lost. I just don't want to accept what we're doing.
You don't want to accept it. All right. 4 over 7. You don't want to rationalize. Cotangent, 7 over 4. Cool. The only ones that are safe. I guess there's a lot of them that are safe. This guy's done. This guy's done. This guy's done. This guy's done. Right? We got to fix these two. How's come?
No, because it can't have square roots on the bottom.
You can't have a square root at the bottom.
You just move it up to the
Right, kind of. Can you guys do these in your head yet?
4 square
Jack's
roots of
like,
65
yep.
over 65.
It's the square root of 65. You're multiplying by the square root of 65, okay? Square root of 65 times the square root of 65
65.
is just 65. It's the square root of 65 squared, okay?
65.
4 square roots of 65. The only other thing that I would have to do is if these two reduce, I would reduce those. Does 4 and 65 reduce? Nope. So there he is. Okay, this one you can do in your head, maybe.
It's the same thing.
7 square roots of 65 over 65. Can you do those in your head this time? This guy moves up and he stays the same. That's kind of like the pattern of when you're rationalizing, yeah? Okay, good. There is that guy. Let's do a little bit more and then we'll be done. Okay?
So the only thing different is we're just actually.
Using right triangles to solve. Yep. Okay, example 2. Suppose that cosine is the square root of 5 over 3. Evaluate tangent. Ugh.
So we have. to
Okay,
make a
how do I
triangle.
start this? Triangle, okay?
Triangle.
Shall we do it? I'm gonna face my triangle this direction. You do whatever you want.
So we know our acute angle is here.
Okay, what is cosine? Oh, you wanna put your acute angle there in the corner?
No, up at the top.
You're gonna put him at the top?
I want to put him at the top like the last one. Can we not?
I wanna put him in this corner. Get used to putting him in that corner. Because if he's in standard position and if that's in the first quadrant, you're gonna want your angle theta to be this corner. So get into the habit of doing that. You're fine if you don't, Jose, but like going forward, we're gonna be doing a lot of them in that corner. Cosine is A over H. Which one is the adjacent side if my angle theta is here?
A is the bottom.
A is the bottom, so square root of 5. H is the hypotenuse, which is this guy.
Yes.
Okay, there's my right angle.
So our,
We got to solve for this guy. Okay,
So
Or
9.
A squared, B squared, C squared. Yep.
5. 9 plus 5 is.
No. Which side is side C?
It's 2.
It's a hypothesis.
That's the answer.
It's 9 minus.
Yeah.
Not mine.
Okay,
Oh.
A squared plus B squared equals C squared. All right, here we go. We got a whole. Everybody's on a different page here. Which side do you want me to be side A? What?
You're right. It's 2.
Which side's side A?
5. The bottom.
The square root of 5? Okay, so square root of 5 squared plus B is one we don't know. C is 3 squared. Okay, what's the square root of 5 squared? 5, right? 5 plus B squared equals 3 squared is 9.
Minus 5 is 4. Square root of 4 is 2.
B squared equals 4. Take the square root. B is 2. Was that too fast?
No.
No? Okay, so there's 2. Now we want to evaluate just tangent, not all 6 of them, right? Just tangent. Tangent of theta.
So over A.
Tangent is opposite over adjacent.
2 over
Opposite. Which one's opposite?
Square root of 5.
2 over square root of 5. Okay,
Square roots of 5
yeah. Do you do that in your head, Tate?
all the time.
All the time? 2 square roots of 5 over 5. Are we good with that?
Wait, why'd you do that?
Because we can have it on the bottom.
Because we don't want the square root on the bottom. So we rationalize. 2 square roots of 5 over 5. Good? Happy with that? Okay, a little bit more. Let's do these 2 and then we'll be done. Okay? These 2 examples. Let's talk about a 45, 90 and a 30, 60, 90. Yeah? Okay, here we go. Are you ready? Write this down. Here is a 45, 45, 90. I'm going to put both of these in the first quadrant. And here's what a 45, 45, 90 triangle looks like.
Does it matter if we make them in the first one? Just asking.
No, but if you position him in the second quadrant, it's going to look as though your number should be negative. Does that make sense? Like if I have a dot over here and I have like this guy, this would be like 135 degrees. Your x coordinate will be negative and your y coordinate will be positive. So that's why I always position my guys so that they go like this. Does that make sense?
Yeah.
If that was confusing, don't listen to that. But there's my 45, 45, 90. Okay, he is half of a box. Do you see my 45, 45, 90? This is how I explain him in geometry class. He's a 45, 45, 90. He is a special right triangle. There's two different kinds, a 45, 45, 90 and a 30, 60, 90. This is what he is, okay? It would be really nice if my box went 1 by 1, right? He's a small, tiny box. He's a 1 by 1 box. So all of these are ones all the way around here, right? And if he's a 1 by 1 box, the hypotenuse is 1 squared plus 1 squared equals c squared, right? 1 squared is 1, 1 squared is 1, c squared, 2 equals c squared, and the square root of 2. That's what this guy is right here, the square root of 2. Good? You see how I got that number, the hypotenuse, yeah? 1, 1 squared of 2. I just made these numbers up. Now, I could have chosen these sides to be, let's say, 5, right? 5 and 5. But this guy would end up being 5 square roots of 2. And then if I do sine, cosine, and tangent with him, I would end up doing like 5 over 5, which I have to reduce, right? So it's easier just to do 1, 1, and the square root of 2. Does that make sense? Yep. Okay? All right? So like in geometry, I don't remember if you guys remember this, but we had a 45, 45, 90 triangle. Let's say this guy is 7, and this guy is 7. What's this guy going to be? 7 square roots of 2. If this guy is 41 and this guy is 41, this guy will be 41 square roots of 2, right? All of those are going to reduce down to being 1, 1 square root of 2, right? So I'm going to leave them at their lowest version and make them 1, 1 square root of 2. Got it? Okay, let me erase some of this junk in here. Come on. Okay, 1, 1 square root of 2. They want sine, cosine, tangent of those guys. Okay. Let's go, I'm going to go sine 45, cosine 45, tangent 45. Okay, we got a decision to make. This is a 45 degree and this is a 45 degree. Which one are you going to use to find sine, cosine, and tangent?
The bottom corner.
The bottom corner?
Yeah, sure.
It actually doesn't matter. But I just get used to using this guy. It doesn't matter if we do this 45 or this 45. Good? How much more do we need? A lot?
So half.
Half. Okay, we need some more. Was that 2 containers? Oh, okay. Okay, we'll need a couple more. What? You will get 2 more? Okay, and then I'll pay you back for it or whatever. Okay, good? All right, perfect, thank you. All right, so let's use this 45. Let's do sine. Sine is OH. Okay, opposite is 1, hypotenuse is square root of 2. So 1 over the square root of 2. We'll fix him here in a second.
Square root of 2 over 2.
Sure. Josie's already fixed him. So 1 square root of 2 over 2. Right? Or just the square root of 2 over 2 because the 1 does nothing, right? Okay, that's what sine is.
So it'd be the same for cosine, though.
No, it doesn't matter. So we could use this angle if we wanted to because opposite here is the same as opposite there, right? Your opposite and your adjacent are the same number. Good.
So it's the same thing.
Cosine is A over H, and A over H is 1 over the square root of 2, or the square root of 2 over 2. Okay, we're going to compare this to your unit circle here in a second. Tangent is OA, opposite over adjacent.
So 1.
1 over 1, which is 1. Yeah? Look on your unit circle really quick. Is sine, square root of 2 over 2, cosine, square root of 2 over 2, tangent 1, at 45 degrees.
Yeah.
Cosine is the x coordinate, sine is the y coordinate, tangent is the
we could just
stuff. What?
and not do this actually.
Yeah, but they're gonna like ask you other stuff besides just that.
But when we do our 30, 60,
And in fact, they're probably not gonna ask you that question.
It does matter whether we use 30 or 60.
True, but you have 30 and 60 on your unit circle.
Yes.
Yeah.
So it would be
'Kay.
1. So it would be half, comma,
It's just
3
switched
squared root of 2.
You're right. You're right. Okay,
I got this.
real quick, we're gonna go through this one faster. I'm gonna do a 30 and a 60. So they're asking specifically for 60, right?
Make 60.
Okay, here is 60. 60, here's my 90, so this is 30. This is a 30, 60, 90 right triangle, right? I put him in the first quadrant, right? Like that. Now we gotta label our like little triangle going on here. This is how I think of a 30, 60, 90. Are you ready for this?
Nope.
He is an equilateral triangle. Ooh, that does not look like equilateral, but whatever. Okay, now, are you ready? Don't write this down. Everybody watch. Here's my equilateral triangle. Okay, if I make this side 1 and this side 1 and this bottom side 1, that's an equilateral triangle, true? But then if I have to do this, I have to split him in half, so this is 1/2, and I don't like fractions. So let's do 2. Yeah, let's make this guy 2, this guy 2, this guy 2, which makes this guy 1. And now we don't have fractions anymore. Got it? So 1, 2, and then if I do the Pythagorean theorem, 1 squared plus this guy would be my side B equals 2 squared, right? C would be my side 2. Okay, so 1 plus B squared equals 4. If I subtract the 1,
Oh, yeah.
he would be, do you guys remember 1, 2 square root of 3? Yep. 1, 1 square root of 2 for a 45, 45, 90. 1, 2 square root of 3 for a 30, 60, 90, right? Okay, so that's how we get that, yeah? So if I'm doing sine of 60, if I'm doing cosine of 60 and tangent of 60, okay, make sure you're looking at the 60-degree angle. We're focused on this one right here. Got it? Sine is opposite hypotenuse. Square root of 3 over 2. Yeah? Cosine is A over H. 1/2. This is on your unit circle. Tangent is opposite over adjacent. The square root of 3 over 1 or just the square root of 3, yeah? These guys, I don't have to rationalize anything, right?
So really all you have is tan.
Yeah, but tangent's also in your unit circle too, because I made him that way.
Well, yeah.
If you did a 30, 60, 90, just watch this. 30, 60, 90, 30, 60, 90, he would be 1, no,
He would be the opposite.
1, 2, square root of 3 like that, right? He's just laid on his side instead. But it's the same unit, or the same sides of your 30, 60, 90. 1, 2, square root of 3, and you could do sine, cosine, and tangent with 30, right? Okay? So on your unit circle, just FYI right here, take a look at this. Here is your 45, 45, 90 triangle. Okay, do you see him? I mapped him out in black. That's your 45, 45, 90 triangle. 1, 1, square root of 2, yeah? Then if I do a 30, or let's do a 60-degree triangle. He's this guy right here. He is 1, 2, square root of 3. And then these guys are just made from that, right? From the unit circle, okay? And same thing with the other one. The 30, 60, 90, this guy is a 1, 2, square root of 3 as well, okay? Yeah? 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 Okay, we're going to stop there. You should be able to get through. I don't know. Does somebody know?
No. Connor?
Connor? Do you know where we can get through? I'm going to guess maybe 30. Try to do up through 30.
Do we think we're going to finish notes tomorrow?
Probably. Okay. I think I'm still recording, actually. What? Perhaps? Okay, this is for Eli and Carter. Goodbye, Eli and Carter.
We can do up to 39.
Up to 36? There is no 39. So 36. Up to 36. You don't think we can? Okay, 36 is questionable.
2 cosine of pi over 6 minus
Okay, there you go.
Yeah, that's